Cool. So sorry for this few minutes delay. We had some network connection issues. So I'm Moshe Golan from the Power BI team. I own advanced analytics and specifically the R integration in Power BI.
Hi, everyone. My name is Justina Lichnik, and I'm also a program manager on the Power BI team, and I specifically work on the customer success team. So what we're really concerned about is working closely with customers, doing things like POCs. I just wanted to highlight a few of the projects we've been working on where R has been really a pivotal part of the integration.
Excellent. Thank you. So yes, this session is not only about learning about the R integration in Power BI. We actually want to show you real use cases of the technology we build. So today, basically, before we start, I want to ask you guys, how many are familiar and actually working with R? Can you please raise your hand? OK, so as expected, most of you are familiar with R, but many of you are not. So we're going to start with a very short overview of what R is and why did we integrate it to Power BI. And then we will discuss the specifics of how R is integrated in Power BI and what we can do with it. And at the end of the session, I want to make sure that everyone here understands how you can leverage the power of R within Power BI. And just to illustrate that, so here, what you see here is a dashboard that I call the Wall of Fame for our R work. And this is already using R visuals or visuals built upon models created with R scripts, with real customers in our preview bits. So you have our information, and I encourage you guys to send me your R work so you can be famous on the Wall of Fame. OK? So let's go ahead and start. So why did we integrate R in Power BI? So first, just some statistics. We have the Rexter Data Scientist Survey, which shows that over 3/4 of the data scientists are using R in some way. And about 1/3 of them are using it as the primary tool. Now, that's not a big surprise, considering that R is built for data science and statistics. But when we compare R also to generic program languages, we see that R comes 6th in terms of the IEEE survey for the most popular language used. And you can see that this is right after the C# native programming languages, which I think is a big statement of the importance R takes place in the development community. So R is widely used, right? The trend of adoption R is increasing. We have more than 2 million users using R already. It is most applicable in statistics and applied science and data science, as we have here. It is considered to be very famous for the rich visualizations that you can do with R, and specifically very important to our essence here in Power BI for the advanced analytics application that you have there with the open community with over 7,000 packages available for you to do things like forecasting, bucketing, correlations, all the cool stuff that you hear here today. You can do that with R. So you can think about R as a Swiss Army knife that allows you to do the things that you cannot do natively in Power BI. We will show you how R can do it. So just to illustrate, and that's taken from the Mats Lanz University, you can see that the thriving community with 700 packages available there. I see that most of you are familiar with R, so probably you know more about it than even myself. So it's readily available for you. And in this session, I want to show that it's very simple to take the work that you already did that is familiar with R and take it right into the Power BI and enjoy the power of the community that already generated these available packages for you for advanced analytics and visualizations. Moreover, we have across the globe about 200 user groups that are sponsored by Microsoft. We support the community, and I'd like to encourage you to follow this URL. The presentation will be shared later, and you can locate the user group closest to your location and take advantage of it. Work with the community and learn. We publish the stuff that we also generate for Power BI with the R community, so it's available for you. Now, for the folks that are less familiar with the R here, I wanted to shortly introduce the Mandelbrot set. Now, it's not about learning about the Mandelbrot set, which is quite complex. It basically defines bounded regions and these beautiful shapes that you see here, but it defines it by mathematical formulas of complex numbers. And this example is actually used by Wikipedia to illustrate the power of R. And the reason is that you can see that in these few lines of code in this screen, you have the ability to take raw data, which is complex in a vector form, apply a package that is already readily available for you, a scientific package, use complex imaginary numbers in that formula, also available by R, by the community, and in a few lines of code, be able to visualize these beautiful shapes representing the Mandelbrot set. So that's just a taste from the scientific community, and we will jump quickly to R in Power BI. So it's already 2 p.m., so I'm sure you already heard a lot of Power BI so far. I'm sure you're already familiar with the basic architecture of Power BI, and I want to show you how do we plug in into that architecture. So first, Power BI as a SaaS, software as a service, available in the cloud. But the authoring tool for Power BI is the Power BI desktop. This is the graphical environment where you build reports and publish them to Power BI. Basically, this is where we integrated R in Power BI to start with. The first part is this R connector that you see here. The vast amount of data connections available for Power BI, over 50 available data connections for Power BI, we added something we call an R connector, which is basically allows you to connect using R to any data source that is not supported by Power BI and supported by R, leveraging, again, the power of the community, and allows you also to connect to using the scripts that you already have, pulling in data from familiar data sources, and transforming them, applying advanced analytics on top of them as you bring them to the model. This is best illustrated with a demo, so I'll pause here. I'll introduce the second introduction point for R in Power BI, and we will go back to it in a few minutes. So we can plug into R, we plugged in R to Power BI to the data sources, allowing you to transform on top of them. And then at the other end of the creation of a report, we also support R to create visuals. And in this part, basically it allows you to plug into the Power BI architecture in a way that your data is already in a model. You can apply R script on top of it, and then use the power of Power BI to visualize it and share it, as we will see soon in a short demo. OK, I think it's enough talk for now. Let's move in and get started. So imagine that I have this beautiful wall of fame posted online, and I want to monitor how many users are visiting my web page. Okay? I'm already collecting my information, let's say in Excel, okay, and I have it here in front of us. And I have this information, it's readily available for me. And as an R developer, I'm used to work in my own familiar environment. I'm going basically to connect to that file from RStudio. Okay, that's the open source R cron. And here we have a short script, basically going through that data, fetching it, and creating predictive data on top of it. So I'm starting with that historical data, and I want to create a predictive model on top of it. So let's see how we do that. So the recommended approach, okay, is to take my script, and we won't go through the detail at this time. Our focus is on the integration. I'm going to take that script, and I'm going to run it in RStudio just to make sure that everything works fine. And I see that it ran successfully, and I can see here that this script actually generated, and you can see here, predicted values. It resulted in some predictive data. So now what I'm going to do, I'm going to copy this information. I'm copying only the R script, of course, and I'm going to move in to the Power BI desktop environment. And you can see here that I'm going to start fresh. This is a new sheet in Power BI. I'm going to the Get Data, and here you will find that we introduced an R script connector. It still marks beta, but by the end of this month, in the new coming release, you will see that our R connector is actually available publicly. It's in production quality, and you're encouraged to go ahead and use it. So let's go ahead and kick it off. OK, I have my R script that worked well in RStudio, and I'm going now to apply it in Power BI Desktop. And you can see that right now, I have my data available for me in Power BI Desktop. So the same predictive data that I generated with an R script in my own environment is now available for me in Power BI Desktop. Now, once it's available, I can load it. And I can start to work with it. So I'm going just to create a quick report. So typically, I would represent a time series in a line chart. Let's go ahead and do that. Okay, I'm going to choose it to be in a daily granularity, and I'm going to pull in also our predictive data. So you can see here that I used R, the Open Community Available Forecast package, to quickly create a forecasting chart available for me in Power BI. Okay, and it's a native Power BI visual. I can do almost everything that I can do with a regular chart. Like I can go here and format it. Okay, I can choose to give it a title or to change the color or whatever I want. I won't spend the time on that right now. I can, of course, let's say I'll copy it here, use any visual that I want. For instance, I can create very quickly a column bar on that and represent my data. So once I finish building my report, I can publish it to Power BI. And at that point, let's switch to Power BI. Yes. It is available for me as any other Power BI report, as you've seen in the keynote, as you've seen in other sessions. I can go ahead and pin it. So if I'll go here, okay, I can pin it to an existing dashboard like I will do now, or I can choose a new one. Now I'll go to our demo dashboard, and you can see this is the new visual that I just pinned. So the stuff that I have created in Power BI Desktop using my R script is available for me now on the service to share with everyone, okay, using the common Power BI sharing mechanism, either through sharing a dashboard or through sharing content packs, whatever is available for me in Power BI. Now again, the data that I pulled in using the R script is available in the data model. And as such, I can also apply other Power BI actions on it. Like, of course, if I want to refresh it, it's available for me as well. I can also apply quick insight, whatever I want. This is a native Power BI model at this point. Now, just a word about refreshing before we continue with the presentation. Sorry. So in order to refresh my data, if you noticed, so far I worked only in my local environment. Okay? I published my data to Power BI, but my R environment was available for me locally on the desktop. Power BI Desktop automatically identifies my R environment, whichever it is. It can be the open source one, it can be the Microsoft open one, it can be any environment of your choice. We will identify it. If you want to change it at any time, you can go to the Power BI desktop options and setting and change the path to point specifically to your R environment. In order to refresh against that specific environment, you are going to need to deploy the Power BI Personal Gateway. Without the Power BI Personal Gateway, you won't be able to access the specific machine in which you run your R environment. So to summarize the advantage, to summarize what we just seen with the demo, so basically we can see that the R connectors allows us to get data and transform it natively in R. The scripts that worked for me in my own R environment are working for me now in Power BI. I can bring it to the model, and once it's in the model, it lives harmoniously with Power BI. I can visualize using the rich Power BI visualization arsenal. It can be native visuals, it can be custom visuals, I can visualize it in any way, and I can set scheduled or manual refresh on top of my data using the Personal Gateway. So at that point, I want to call in Justina to show you how this functionality is used by real customers.
Cool. Thanks, Moshe.
Yes.
Perfect.
Sorry, you can skip that.
Yep. Cool. Thanks a lot. So the specific example I wanted to talk about from the get data perception is one that we see a lot with customers, which is, out of curiosity, how many of you guys have heard of Azure ML? OK, so I'd say about half-half. So Azure ML is another Microsoft tool. It's the Azure Machine Learning Studio. And what you can do in Azure ML is basically build your own predictive models. And I'm going to show you the Machine Learning Studio just in a second. It's super easy. You drag and drop. You have a vast choice from the library of machine learning models we support. They're MSR built, so they're really, really good quality. And what a lot of people actually want to do is use Azure ML to build their super sophisticated predictive algorithms and models, and then actually visualize that data inside Power BI. And actually, it turns out that R is this great glue between these two products, which I'm going to show you right now. So before I jump into the case study, I actually want to just visualize and show you guys a very simple example. I'm really sorry if you've already been to Ted's session, because this is going to be a bit repetitive, as I've just found out. But let me just jump into the browser. Where's the browser? There we go. Oh, God, I'm blind. Sorry. There we go. OK, so let me jump into, let me start out with just talking about Azure ML for a second. So this is the Azure ML Studio. And what I actually have over here is a very simple experiment. What it's using is the Titanic dataset, which, yeah, if you've been to Ted's session, you're familiar with that. And what it's basically doing is creating a predictive model and predicting how likely someone is to survive the Titanic, basically. And so just to show you Azure ML, you can basically start with your data, do some basic data cleansing steps. You then actually choose the model you want to run. You can drag and drop models and just switch them in and out really, really easily. And then you train your model, and you score it to find out how well you're performing. And so once you've actually built your machine learning model, what you can do is you can publish it as a web service. And once you publish it as a web service, you can go ahead and call it and send it fresh data, and it'll get you back new predictions. So what I've done is I've already published this as a web service. And what's really cool is you can actually call the web service using R code. So maybe so if you could see where I'm going with this. I've got my Titanic demo over here. I've got my code, which basically calls the predictive experiment and then returns me back my scored probabilities. So I'm going to just jump into Power BI. I'm just going to create a new sheet over here. And again, I'm going to go ahead and click on Get Data. I'm going to use the R connector over here. And so what this R script is actually going to do now is it's calling out to the Azure ML web service. It's sending it new data, and it's going to get back predictions around this Titanic data set and how likely you are to survive given your various information. So for example, over here we see, we've got information like passenger class, gender. So we've got here passenger class 3, male, young, score probability of nearly 0. So yeah, you get the idea. So I'm just going to bring this data in. Okay. And just very quickly, I'm just going to select this and change the data type to a number so I can visualize this. And so what I can do now is, for example, visualize my average scored probability that has come out of the machine learning model. And I can, for example, visualize it, let's say, by something like gender. So for example, I can see here, that shouldn't be a currency, but females are a lot more likely to survive the Titanic than males. We've got nearly an 80% probability of surviving. So I just wanted to basically just quickly show you guys AzureML and how AzureML works for those of you who are not very familiar with that. What I'm going to jump to now is actually a real customer scenario we've worked with where it's basically we're using AzureML in a very similar fashion to over here. We've trained a model inside AzureML. This particular customer is a retailer, so he has a chain of stores. And basically, what he's interested in finding out is a lot of time series analysis, forecasting, understanding for a given store at a given point of time, how much revenue am I going to be making from that store? So actually over here, the first visual I just wanted to highlight to you guys is very similar to the one Moshe was showing you, where you've got your score probability, and you can kind of see how the machine learning model is learning and what kind of predictions it's making over here. So I can see I've kind of got a bit of a seasonal trend where generally I've got Mondays is when things pick up. From a revenue perspective for the store, then things kind of go down. Then we have another peak on Friday over here, and then during the weekend things drop. So I can basically, similarly to as Moshe was saying, I can visualize my predicted scored probabilities inside Power BI. But I actually wanted to talk about something slightly different, which I personally think is really, really cool, what you can do with this kind of integration. For those of you who have used AzureML, AzureML is great for building very sophisticated models. What it's not particularly great for is understanding and diagnosing how well your models are actually performing. So if I want to see where I'm performing well and where I'm not performing so well, I can get a general understanding of how well my model is performing, but not where I'm performing well and not so well. And so what I've actually done here is I've plotted a few other things which are actually, for this particular customer, being a great tool for diagnosing basically from the analyst perspective. So I'm plotting over here my mean absolute error and the number of observations by store. So what is the mean absolute error? So when I run a predictive model, I basically get an understanding of how far away am I approximately from my actual real observation. In this particular case, this is data that I already knew what the real values were for. So I can say, hey, on average, from using my real data, this is how far my machine learning model is deviating away from the real results. And I'm visualizing this on a store-by-store basis. So I can see which stores I'm performing really, really well on and which stores I'm not performing that well on. And I've actually sorted this graph by the mean absolute error, so I'm starting with the stores I'm basically predicting the worst. And I can see, first of all here, these first couple of stores. This is maybe quite intuitive. I have very, very few observations for these stores. So I can go ahead and drill into the store and see, if I look over here at the bottom right-hand side, I basically barely have any observations. So it's actually not a surprise that my machine learning model isn't performing so well in that particular case. This is something I might go back to my business user and say, hey, for these stores, do not use the forecast. I might go back to my team and say, hey, why are we not collecting better quality data over here? I get kind of instant feedback around that as an analyst. But then I see some other interesting things. I see stores where I actually have a lot of observations, but I'm still not performing that well in relative to some other stores. So for example, over here, I've got 160 observations, which by this model is actually quite a lot, but things aren't going that great. So let's see what's going on. So if I look at over here again, let me actually make this a little bit bigger. The first time around, you see this very nice, clean seasonality we've talked about. When we drill into this particular store, though, the seasonality is kind of all over the place. There is no real seasonality. We see that the model is first over-predicting, it then under-predicts because something happens in between. I'm not really sure. We can actually get some more details around this over here by looking at the day-over-day forecast change, where basically I get an idea, so from the average, how far do store sales deviate day by day. So in the seasonal model, we've talked about Monday and Friday being our top days and our weekend Saturday being our bottom days, which we can see over here. When I drill into this, you can actually see the seasonality is completely different. My Mondays and Fridays are actually my worst performing days, and Saturdays I have a lot of revenue coming in. So perhaps from an analyst perspective, I need to maybe potentially look at creating a separate model because maybe some stores for some reason follow a different seasonal pattern. I definitely shouldn't be using this particular model to predict things for this case. Or maybe there's some anomalies in the data. I can go again and follow up around that. But from a business user's perspective, this is super helpful because they now know which models, which stores they can accurately rely on with their forecasts. And from an analyst perspective, I can go ahead and deep dive into my data, which I wouldn't be able to necessarily do using Azure ML. So this is a really, really great kind of synergy between our two tools and with our integration to show kind of the full end-to-end. And what's really great about this, again, is going back to Moshe's point about uploading this to the service. What I can now do is actually operationalize my machine learning models. If I set, let's say, a scheduled refresh for every day, I'll have my machine learning model rerun every day in the service, scoring new data that's coming in, which is really, really, really helpful from an analyst and a business user perspective. So yeah, this is the scenario I wanted to highlight for the get data scenario. So I'll let now Moshe jump back in and talk a little bit about the R visuals. And hopefully I can actually find the tab this time around.
Thanks, Justina.
There we go.
It's very awesome to see that the R connector is used by real customers, and Justina is leveraging that. Happy to see that. And now we will move to the next investment we have. So let's see. One sec. OK. So we'll start with a quick demo to discuss the R visual aspect of the power of R and Power BI. OK, this is what I'm looking for. So what we have here. So first, let me just give you some background about the data so we understand what we see here. Basically, this is an R visual. And in a sec, we will understand how it works. But what we see here, so we understand how the data manipulates, that's a correlation plot, a very simple correlation plot. And it looks on the correlation between different car attributes. So just to give an example so we can follow up later, the dark blue represent strong positive correlation, while the lighter colors represent neutral correlation, and red colors represent strong negative correlation. So to illustrate that, for instance, we see that we have here a strong correlation between car's horsepower and the number of cylinders that the car has. And it makes sense. A car with 8 cylinders is more powerful than a car with 4 cylinders. But again, a small reminder, correlation is not necessarily causality. Okay? It's just correlation. And if you look at the correlation between horsepower and the number of gears that a car has, we see a neutral correlation. So let's keep that thing in mind and go back to our R visual, okay, and investigate that. So first, we see here that this R visual, if I'll open this one, what powers this visual is just one line of code. Okay? You can see here library, core plot. This is the library that powers the visual with a simple call to this function with a few parameters to control the visualization. What we did in Power BI, we automatically bounded the data. And you see here this grayed out area, which bounds the data that we have here. For example, I can remove carburetors. And you see that the visual adapts. We automatically bounded the data to the visual. And now I can use my R script to basically automatically work on that data. I can change the script quickly just to illustrate that everything is live, and just controlling some formatting aspect. I can run it live here. Okay? And you can see that I changed my visual. I can change it back. Okay. And now let's keep our original observation. Okay? You can see that the visual is live, it's connected, but the real power of bringing this R information and the R visual into Power BI is that now I can use the power of the Power BI desktop to actually manipulate this data. So what I have here, I have another visual that representing the distribution of the cars between sport cars and regular cars. So let's see what happens when I click sports cars. Okay? And now let me just to show you, we can see that the correlation had adapted. Okay? The data, basically what we called cross-filtered only to correlations of data for sports cars. And we can see that right now, if we look on horsepower, there's actually is a strong correlation to the number of gears and also to the number of carburetors there. Okay, so the data is live, and I can manipulate and explore it. Okay, but everything we saw right now is on the desktop. Again, it requires R to be installed on my desktop, and I worked with my local R. But now I want to share it with you guys. So I'm going to publish it to the service like any other R visual or Power BI report. And in Power BI service, I'm going to see my report. And here comes the magic. Now, a reminder, in Power BI service, my report lives in the cloud. Okay? But I still want to share it with you guys, and I want you to be able to get the same insight that I saw. So you'll be able to cross-filter the data and work with it. So what we did, we worked with the AML team to integrate Power BI with Azure Machine Learning. So you can see that now when I pressed on sports car, the same visual cross-filter, the same insight is available also on the cloud. The magic beyond that is that we basically take the R script, including the specific data that is required to generate the visual, and we pass it on to Azure Machine Learning, and Azure Machine Learning returns the visual for us, and everything works like magic. So as an analyst, I needed my R environment to build the visual, but as consumers, once I share this visual with Power BI, whether on the report or on a dashboard, it's available seamlessly. Right? So I think that's a very powerful thing. So you can take the power of R that you have locally, and now with Power BI, share it across. So once I'm available in Power BI, of course, everything is available for me. I can go ahead and pin this visual like any other visual. And let's go ahead and see that here. It will be available for me on the dashboard. Okay? I can share it with everyone. I can refresh it if I want to. Everything is available for me as any native visual in Power BI. The only constraint that we have at the moment is that I can cross-filter from any visual to the R visual. I cannot use the R visual to cross-filter another visual. OK, so let's quickly recap what we just saw. So basically, now we use the power of R to calculate and transform data that is already in my data model and visualize it with the richness of the visualization available with the R open community libraries. I was able to do that. Once the visual is available in Power BI, it lives harmoniously with other visuals in Power BI. I can pin it to the dashboard. I can share my dashboard. I can package it in content packs. Whatever I can do in Power BI, I can do with my R visual. So to get you started quickly, just a reminder of what we had here. You do need the Power BI desktop in order to create the report. You do need a local R environment to create the R visual and run the R script, very similar to the R connector. But as a consumer, you don't need anything installed. You just use Power BI as is. The script needs to generate a data frame in order for us to pick it up and load it to the model. And in terms of licensing, while the R connector is available with Power BI Desktop and it is available for free, the R visual requires Pro license. It's not available for free. But the good news is that I can still share an R visual. The limitation will not be on the simple consumption of the R visual. If I get a dashboard, I will see the tile. The limitation is with manipulating that tile, refreshing it, cross-filtering that tile, filtering it, or pin it to share it further. Only pro users can do that. So at that point, I'd like to call Justina again to show you how our visuals are used by real customers. Please, Justina.
Oh, thanks, Moshe. All right, let's just jump straight into Power BI then. So this is a project that's actually still ongoing. This is some work we've been doing very recently, but I actually really think this R visual is really cool. So even though it's still sort of in the process of being made and us working with the customer, I wanted to just share it with you guys. So for those of you who are familiar with R, with Azure ML, this is a decision tree that we've built. The customer is, again, another retailer. This time it's a hardware retailer, so they sell all sorts of things from like shovels to paint to tools. And so what we're trying to do over here throughout this analysis, we're trying to do some product analysis about like which product gets sold together, as well as, again, looking at how much revenue this comes in from a particular store. But in this particular case, we're not really trying to predict for the future of, we expect, for example, tomorrow, this is how much revenue we're going to have from, the store Y or store Z. What we're trying to give the business users, effectively, is a way for them to understand their business and understand the top decision rules, and top decision rules with regards to when, they can maximize their store sales or when their store sales are the lowest. And I'm going to go into this in a little bit more detail. But for those of you who might have, let's say, used like boosted decision trees and things like that inside Azure ML, you'll know these are super complicated. They have thousands of splits, and they generally have very good accuracy. Over here, what we're going for with the R integration with Power BI is interpretation. So the decision trees are a little bit simpler, but it does mean that as a business user, I can kind of go through them and understand what all the different splits mean, and really start to understand my business better, which is what we're going for. So in this particular case, again, I've just drew up a quick decision tree. And what we actually see throughout it is my sales from 14 weeks ago is sort of dominating a lot of the decisions. I can kind of see it as my top split, and then I can see it again back down here and again. So maybe I don't want to actually be using something like my 14 weeks of sales, sales 14 weeks ago. Maybe it's too strong of a feature. So if I want to remove it, again, it's super interactive and super easy to use. I can just go ahead and click the X over here, and my decision tree re-renders and reruns based on the new features that I've given it. So what I really, and believe me, I'm a huge R fan. I actually started using Power BI after I started using R, and I was sort of a bit skeptical. I'm like, well, I can do everything in R. Why should I use Power BI? But what I really, really appreciate about the Power BI integration is, how interactive and how, I can just drag and drop variables in and just things rerun. I don't have to now define, 100 different models. I can just slice and dice or just bring in filters or bring in, new variables, and things just rerun really quickly. So I really appreciate that. So just to spend some time on looking at the visual and help you guys understand a little bit what's going on, if we start here at the very, very top, what we actually have here is the top kind of decision rule, the top decision split. And what it does is, here we have 100% of the data, and we have a condition that's being, that we're kind of evaluating over here. So this is actually looking at whether tools are on promotion, or not whether tools are on promotion, but how much have we reduced the price of tools by. And we actually find that when we reduce the price of tools by a lot, that decision split happens over here. We actually increase generally the amount of revenue we're making from stores. So all the kind of high revenues, you can think of it, are here. All the kind of lower revenues are here. So based on this decision rule, we find that, again, if we have tools that are heavily discounted, actually our sales kind of goes up a lot. Then the next decision, I'm just going to go through like 3 of these decision rules. I won't bore you guys with this. But the next one is actually looking at the seasonality of paint. So we've kind of looked at, when, what I mean by seasonality of paint is high seasonality means, that there's a lot of generally demand for paint. Low seasonality means that's the time of the year when people aren't buying a lot of paint. And we actually find that when tools are high on promotion and paint is very low in demand, that it seems to be that that's when we're maximizing our sales. So again, I'm just brainstorming and hypothesizing with you guys. We're still kind of working out the process here, but maybe, maybe this is to do with the time of year. Maybe generally people buy a lot of tools in winter, and maybe sales for paint seasonality is maybe low in winter. I can go back to my forecast and actually look at my seasonality for paint and figure that out a little bit, go back, talk to the business user, figure out what's going on. That's sort of what my decision trees tell me. And finally, it seems that in settings of when my sales are high, I'm actually, my population is actually below 29,000. which is actually a bit surprising for me. I kind of assumed that when I'd have very, very high population densities, and when I say population densities, I mean for the store in that kind of area. So I'm looking just as a part of, like an attribute to the store. What's general population density around the store? I actually thought that when we'd have super high densities, then my sales would be higher. But maybe my hypothesis here is potentially when we have very high population densities, people are more likely to go to a big supermarket and do everything, all their shopping there. Maybe they live in apartments, so they don't need to service their apartments as much because someone else takes care of that. Again, these are some things we can run through with the business user. But as a business user kind of finding out about these decision rules, I can now start thinking about things like, okay, how do I allocate my marketing budget? Based on seeing where we sell the most, let's first see, is that because we actually target mid-markets a lot with our marketing? Or are we actually targeting our kind of big population densities, high cities, but that we're not getting money out of our marketing budgets? So I find out these business rules, and I can actually start making data-driven decisions as a business user based on some of the data I'm finding out about here. And I really think that the synergy between this R visual integration and Power BI is something that's really, really powerful for both the analyst and the business user in this particular case. So yeah, I'll invite Moshe to wrap up.
So it's great to see the R visuals used in practice by customers. We saw it now used for decision trees. We saw it earlier for predictive analytics. We see that we can bring the power of R into Power BI, and the synergy between it basically empower and create much more value among the two. To wrap up, I wanted to share with you guys, a few tips and tricks that we kind of learned from working with customers and from our experience to work productively with our visuals in Power BI. The first one is, as you noticed across the demos that we saw, Power BI is all about exploring and changing your data. People can, in the Power BI desktop or online, can change their field selection, can cross-filter and filter. So as a result, the Power BI, the script embedded in the R visual will receive different data at each time. So building such scripts should be resilient to start with, considering a data set can be empty or with a different combination of the filtering or cross-filtering or data selections available. So this is one thing to keep in mind. Another thing is the data types, okay? As people play around and explore the data, they can bring in numerical or other data to the visual, and the visual needs to be able to work with that. Again, the dynamic manipulation and working with that visual is different than the closed environment that people are used to when they're publishing an app built in R. So this is something about the scripts, basically resilience to change. The other thing is about the environment. It's very recommended to run first the R script in the local environment, your chosen environment, whatever it is. It's easier to debug there. You have the power of the rich developer environment within it. Only after it works there, it's recommended to try it in Power BI. And then I'd like to call out that while you're working on your own environment with specific packages in Azure Machine Learning, there are some limitations, which the packages installed on Azure Machine Learning may be of a different version or may miss altogether. This is something we're working on, of course, and we can fix as we progress. But it's very recommended to check against the service your report before you share it, to make sure that the consumption online is adequate for your business needs as it was in the desktop. Now, to wrap up, just sharing a couple of more examples of real usage, just touching on very common usage that we saw online. And we want to refer you guys, and it is available in the references in the deck, to go ahead and check further. So Ryan Dustin owns a blog about BI, and he has one specific for the integration of R and Power BI. And you can see that he did some major work here, analyzing schools' distribution and enrollments in the US. He also did some power plant representation over maps that we discovered that many of our customers use our capabilities with maps to visualize data. Another interesting one was done actually by our team, by a data scientist in our team that was investigating graph theory. And you can see here that you can create really awesome representative graph visuals to check things like closeness and betweenness, basically graph properties. And the last one, which is my personal favorite, is that we have an application actually right now living in Power BI. Basically, David Eldersfield, also a blogger, and has actually a blog and a tutorial about using R in Power BI on the net. The reference is on the deck. Managed to creatively create a game in Power BI by using 2 R visuals, which one of them basically is like a control knob to try and sync a ship on another visual. And I like this example because it shows the creativity that people can do using the R language. They have the full power to do whatever they want. So that's a nice one that I want to wrap up with, that basically illustrate that R in Power BI is like an Army Swiss knife that you can use to do the things that you cannot do otherwise. And of course, you can do to use the advanced analytics available with Power BI and the advanced visualizations available with R. So with that, to summarize, we had 2 different capabilities we showed you guys today. One is connecting with R to bring in your data, transform it, and create advanced analytics on top of it before you bring it to the model. The other one is working on top of your existing models and leveraging R to transform it and do advanced analytics and visualize it in Power BI. At this point, I'd like to open for Q&A. I guess we have a couple of minutes, so we can take 1 or 2 questions. Anybody? Yes, please.
Is there a plan to integrate better integration with R that you'll be able to run it inside Power BI and try it out? Better debugging tools?
So are you talking, can I try and rephrase and let me know, are you rephrasing to operationalizing R in Power BI in a way that you will have it available with predefined capabilities?
Just like today, like M, for example, you click on the thing, you get an editor, you can try it out.
Yeah.
R is a little bit kind of an afterthought. You have to go and get the code, you have to debug it outside of the tool. If there's a change in the data model, you have to go to the
Right. And that's excellent feedback, and thanks for telling us that. And I do encourage everyone to share their feedback in the user voice, and we look at that. And the short answer is yes. We are looking in improving the developer experience in general. And yes, and here we touch on 2 capabilities, and of course we have a roadmap of things that we are going to work on. Thank you. I can take 1 more question. Yes, please. So yes, what we illustrated earlier with the correlation plot, for instance, we generated the R visual on the desktop, but once we publish it to the service, okay, you can imagine ggplot there as well, okay, it will run against AML and will be serviced automatically for the consumers. So yes, the script lives also in the cloud. Thanks. Okay, 1 last question, please. So this is a current limitation that we have right now. So there is a gap between packages supported in general and packages supported in AML. You will get, once you put your visual on the service, you will get a clear message telling you that the package is missing, okay? So you won't share that report with others, okay? And you'll be able to either use another library, another package, or go around that. We are looking in the future, of course, to support better experience with that. Okay, so thanks for coming to this session. I'm very happy to see a full room. Thanks a lot.